my dear students of class 11. So today we will be discussing about limitations of Bohr's atomic model. So in our previous class we had discussed about postulates of Bohr, and today we will be discussing about limitations of Bohr's atomic model. So Bohr's first limitation is hydrogen. He explained spectral line for hydrogen, and hydrogen is only single electron containing atom. So this theory fails to explain the spectral line for multi-electron atoms. So the first limitation is this theory, Bohr's theory, fails to explain the spectral line for multi-electron atom. Okay, so he just gave us explanation about the hydrogen spectral line. Number two limitation is we have seen that Bohr talked about fixed circular orbits, and he told that it is planar, means those electrons will revolve around the nucleus only in one single plane, which is not true. So later on it was found that these electrons, they revolve around the nucleus in three-dimensional space. So the second limitation is what? It tells us that electrons revolve in fixed circular orbits, in one plane, circular orbits which are planar. Planar means they are lying on the same plane, but actually this statement is wrong, because actually the electrons, they revolve around. Actually, electrons revolve around the nucleus in three-dimensional space. So we discussed about two limitations. The third limitation is that, now since he has talked about fixed circular orbit which are planar, now this is wrong, because actually now today we will be discussing about Heisenberg's uncertainty principle. Now that tells us that you will not be able to, please listen carefully, you will not be able to exactly calculate both position and momentum. Momentum, we can say velocity also. So you will not be able to calculate or locate the exact position of electron. So Heisenberg's uncertainty principle tells us what? We will not be able to calculate both position and momentum of an electron simultaneously. Now, here, when we talk about fixed circular orbits, planar, that means this is completely wrong. So, number three, Bohr's theory assumes the knowledge of what? The knowledge of definite this position and velocity or momentum. The Bohr's theory assumes knowledge of definite position and momentum. By momentum we mean P equals to mv. So we can say velocity also. This V stands for velocity. So definite position and momentum of electron, which is not true according to Heisenberg's uncertainty principle. Now let's discuss about the fourth point. Okay, the fourth limitation of Bohr's atomic model of the atom. The fourth limitation is that, see, here he explained spectral line for hydrogen, but he could not explain the relative intensity of this spectral line. He could not explain the relative intensities of spectral line. He could not explain the relative intensities, okay? The relative intensities of spectral line. Relative intensity was not explained by Bohr's theory. And the last failure or the limitation of Bohr's theory is, now see, when this spectral line, this even single spectral line are made to pass through, okay, electric field or magnetic field, then what will happen? It gets split into more finer lines. Now this was not explained by Bohr's theory. Now, whenever the splitting of a spectral line takes place under magnetic field, then that is known as Z-Men effect. So he could not explain the splitting. He could not explain the splitting of spectral line spectral line on application of magnetic field. Now this is known as what? Splitting under magnetic field is known as Z-Men effect. So Z-Men effect and on application of electric field. And the splitting of this spectral line under electric field is known as Stark effect. Stark, S-T-A-R-K, okay? It's S-T-A-R-K effect. Stark effect. So these were the main limitations of Bohr's atomic model. Now after this, there was new theory given. Now it was based on quantum mechanics. Now we will be discussing about quantum mechanical model of the atoms. So here, now we will be discussing about the characteristics of electron. Till now, we know that electron will act as what? Particle. That means we have discussed about the particle nature of electron. Now this quantum mechanical model of atom says that, and it was first said by de Broglie. Now, this a more satisfactory model of the atom came after the suggestion of de Broglie in 1924, where he told that in de Broglie's theory, he told that matter and hence please listen carefully, matter and hence electron-like radiations has a dual character. So he talked about dual character of electron. Okay, that means electron will show both properties of a particle as well as of a wave. So we are going to discuss about quantum mechanical mode of the atom. Quantum mechanical mode of the atom. So first who came up with the idea? De Broglie. He told that, just how I told, matter and hence electron-like radiation will have dual character. So this portion is very important. Dual character, okay, of electron, and dual character means particle as well as wave character. So it tells that electron, okay, and other microscopic particles, whenever they are in motion, now they will act as what? Wave. Their properties will be that of a wave. Okay, so he talks about dual nature of electron, and dual nature, please listen carefully, it is both particle nature and as well as wave nature. So he told what? According to de Broglie, all material particles in motion possess wave character. So all material particles in motion, please remember, in motion will show or will show wave characteristics or nature. So, okay, and now he also tells that if electron shows this wave character, means any wave is always associated with what? Wavelength, okay, lambda. Therefore, he came up with the idea that any particle, if it has a mass m and is moving with a velocity v, okay, then its wavelength can be calculated by using this formula. This formula, please look over here, lambda equals to h by mv. Okay, this lambda is de Broglie wavelength. This is de Broglie wavelength. And m, you know, the mass of the particle, v is the velocity, and h, in previous video also I have told this h is a constant which is known as Planck's constant, and it has a constant value. Okay, so any particle, let me remind, any particle, if it is in motion, that means it shows a wave character. Now if it is showing a wave character, then it should be associated with certain wavelength, and this wavelength is given by this formula, lambda equals to h by mv, where h is the Planck's constant and this lambda is de Broglie's wavelength. Okay, now let's discuss about Heisenberg's uncertainty principle. So now we are going to discuss about Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. Now this Heisenberg uncertainty principle is very simple, and I have told while explaining the limitation of Bohr's theory. So Heisenberg, he stated that for a microscopic particle, microscopic very minute particles, you will not be able to determine both position as well as momentum, okay, at the same time. So let me repeat it once again. Heisenberg's uncertainty principle states that we will not be able to measure or identify both position as well as momentum of a microscopic particle simultaneously. Okay, so let me write this definition. So it is impossible to determine simultaneously both position and momentum. Okay, both position and momentum, okay, of a particle or a microscopic particle with absolute accuracy. So both position and momentum of microscopic particle at the same time with certainty or with absolute accuracy. Okay, it is impossible. Please remember, it's impossible to measure both position and momentum of a microscopic particle. He talks about microscopic particle, and this is very important, micro. So if I write this in mathematical form, then what can I write is the change in position, the product of change in position and the change in momentum, that is denoted by P. Okay, P is a symbol for momentum. Please don't forget this. P is a symbol for what? Momentum is greater than equal to some constant value. Some constant value. Please remember, this is greater than equal to some constant value, and later on it was found that this constant value is h by 4 pi. So h, you know, it is Planck's constant. So this is the mathematical form of Heisenberg's uncertainty principle. This is change in position, okay, and this is the change in momentum. Now from these two expressions, this expression as well as Brogly's equation, that is lambda equals to h by mv, you might be getting some numericals. So you need to practice numerical based on these two expressions. And in your book, you have plenty of solved numericals. Please have plenty of numericals based on these two equations that we discussed today, de Broglie equation and Heisenberg's uncertainty principle. Please practice them properly. You have some solved exercises on numericals as well as you have some unsolved ones. So please solve the unsolved these exercises. Now let's discuss about significance of Heisenberg's uncertainty principle. Now the first point about its significance is that this principle hits very hard at Bohr's idea of definite trajectory or path of microscopic particle like electron. Bohr had told us that electrons revolve around the nucleus in certain fixed circular orbits which are planar. Now this is hit very hard by what? Heisenberg's uncertainty principle, where Heisenberg tells us that it's impossible to measure simultaneously both position and momentum of a microscopic particle like electron at the same time. So the first is that it hits very hard at Bohr's atomic theory of definite path or trajectories. Why? Because for a microscopic particle, if you want to get its position, then we need to supply some photon. Now the energy of this photon itself is sufficient enough to displace this minute particle from its initial position. Therefore, we will not be able to measure both momentum and this position of microscopic particle like electron simultaneously. The second point of significance is that this theory is not applicable in our day-to-day life. Why? Because in our day-to-day life we deal with macroscopic particle, that means bigger particles. So this theory is only for microscopic particle. It is not applicable for our daily life. Why? Because in our daily life we deal with macroscopic particle. So with this we come to end of today's class. Now please, whatever I have taught, please keep on revising them. If you have any doubt, you can always contact me. So in our next video we will be discussing with quantum numbers, and for that understanding of all these topics are very, very important. Keep yourself focused in your studies. Okay? So take care. Bye.